Welcome again. We need to solve an interesting yet simple problem once again. It says two capacitors are connected in series. The first has a capacitance C1 and a maximum voltage. It can be the stand is V1. The corresponding values for the other capacitor are C2 and B2. What is the maximum voltage that this combination of capacitors can be paid? So capacitors are connected in series. So their capacities add as reciprocals, that is 1 by C. The equivalent capacitance can be found simply by writing 1 by C1 plus 1 by C2, that is C equals C1 C2 by C1 plus C2. We know it already. And when connected to a voltage source V, the charge on its combination, on this combination C1 C2 in series as equivalent capacitance is C. When connected to a voltage source V, suppose that V, the charge Q on this combination will be Q equals CB. So it's going to be C1 C2 by C1 plus C2 into B. And since this charge appears on each capacitor in series, it must not exceed the maximum charges for either capacitor, because in case of C1 it can be Q1 equal to C1 V1, and in case of C2 it will be Q2 equal to C2 V2. And let us assume that Q1 is less than Q2. Then Q1 should appear on both the Q1 should appear on both the capacitors of this combination, and in this case Q1 should be that means Q should be less than equal to C1 V1, because that means C1 C2 by C1 plus C2 into B, it must be equal to or less than C1 V1. And if you like to manipulate it, you will get the result as B is less than C1 plus C2 by C2 into V1. And I think this is the result. And in case if C1 V1 is equal to C2 V2, then we simply get that V1 is less than C2 V2 by V1. Just place C1 equals C2 V2 by V1 and you will get it. And the result will be V is less than C2 V2 by V1 plus C2 from here, divided by C2 multiplied by V1. You get it as equal to V1 plus V2, and you can consider other cases related to it as well. So this was a simple problem. Thank you very much for watching.